Okay, so how does a city actually stay above water? You're probably picturing something obvious. A big wall along the river. A concrete barrier at the coast. Some kind of visible line between the water and the people. And that picture isn't wrong, exactly. It's just almost entirely beside the point. Because the systems that actually keep the world's biggest cities dry are mostly invisible. They sit underground, out of sight, beneath streets you walk on every single day. And they have a problem that almost no other machine on Earth has. When they work, nothing happens. That's the product, nothing. The flood that never comes. The water that never reaches your front door. The completely normal Tuesday that never turns into the worst day in a city's history. Sounds simple. It is not simple. And the story of how cities stay above water, and how they sometimes stop staying above water, is stranger and more expensive than almost anyone imagines. But before we get to the machine itself, you need to understand something about the ground you're standing on. It's not natural. Most of the great cities that rarely flood are sitting on land that is, in some cases, below the water around them. Tokyo's low-lying eastern districts sit at the mercy of rivers that cut straight through the city and a bay that could push water in from the sea. The Netherlands, a country most people picture as flat farmland and windmills, has somewhere around a quarter of its land below sea level. These are not places that happen to be dry. These are places that are kept dry. Every single day, that condition has to be manufactured, at enormous cost, by machines you will never see. There's no resting state where the danger goes away. There's only a constant, expensive act of holding it back. Which means a dry city is not a place, it's a machine, and the most important parts of that machine are the ones doing the least visible work. Think about what that does to the way a normal person sees their own city. You walk out your door in the morning, the street is dry, the sun is out, and you think, well, this is just how it is. Dry ground is the default. Nobody looks at a sidewalk and wonders who's holding the water back. Nobody wakes up and thinks about the billion-dollar machine that ran all night so their basement didn't fill. The system's greatest achievement is that you never have to think about it. And that's precisely the problem. Because the moment you stop thinking about something, you stop valuing it. And the moment you stop valuing it, you start looking for ways to stop paying for it. That single illusion, dry ground looks free, is how almost every flood disaster gets started. It's not the weather that kills cities, it's the gap between how safe the city looks and how much work it takes to keep it that way. This is the part that surprises people. Flood protection is the only product in the world whose success looks exactly like nothing happening. Think about how every other business on Earth proves it's working. A restaurant proves it by selling food. A factory proves it by shipping boxes. A power plant proves it by lighting up a city. But flood protection proves it by doing absolutely nothing. The barrier doesn't move. The pumps don't run. The streets stay dry, which is what they'd look like anyway if the system didn't exist at all. There's no moment where you see the money at work. There's only the absence of a disaster you never saw coming. That's not a small detail. It's the single most important fact about this entire subject, because it determines everything that happens next. How these systems get funded, how they get maintained, how they get cut, and how they eventually fail. So let's look at the biggest example on Earth. It's called the Metropolitan Area Outer Underground Discharge Channel, and you will not find it in any tourist guide. It sits beneath the outskirts of Tokyo, and it is one of the most astonishing things humans have ever built that almost nobody knows exists. Imagine walking down a normal street in a normal suburb, and somewhere below your feet, there is a cathedral the size of a small mountain. That's essentially what this is. 5 enormous intake silos, each one around 65 meters tall and wide enough to hold the Statue of Liberty, drop straight down from the surface. They connect to more than 6 kilometers of tunnels running 50 meters underground, supported by 59 massive pillars, each one standing in a chamber so large you could fit an entire city block inside it. And the whole thing is designed to do one thing: catch rivers before they flood the city. When a typhoon dumps more water on Tokyo than the rivers can carry, the overflow doesn't race through the streets. It falls into these silos, pours through the tunnels, and gets held in a reservoir that can swallow more than 100 Olympic swimming pools before the pumps even start to strain. The total price tag was 230 billion yen. That's somewhere north of $1.5 billion, depending on the year you do the math. And for most of its life, the machine just sits there, empty, dark, waiting. The most expensive room in Japan, and almost nobody in Japan has ever seen it. People have started calling it the Underground Temple, and if you've ever seen footage of it, you understand why. It looks like a set from a science fiction movie. 59 pillars rising into darkness. Water cascading down the walls of those giant silos like a waterfall in reverse. The whole thing lit like a cathedral, because it essentially is one. But the comparison that matters isn't architectural, it's economic. A cathedral is built to be seen, to inspire awe, to remind people of something they're supposed to believe in. This machine is built to be hidden, to be forgotten, to do its work in perfect silence. And the difference between those two things is the entire reason flood protection is so hard to keep alive. A cathedral gets donations because people can see it. This thing gets funding only because a handful of people somewhere remember what happens when it's not there. So why would anyone build a $2 billion cathedral that spends most of its time doing nothing? Because of the water it was built for. Tokyo is one of the most extreme examples on the planet of a city that lives on borrowed ground. It's massive, it's dense, it's built on low-lying land, and every year, the sky drops enormous volumes of water on it in short, violent bursts. When a typhoon comes in, the rivers that run through the city don't just rise a little, they can rise to the point where they'd spill over their banks and push straight into neighborhoods where millions of people live. And here's the counterintuitive part. A wall along the river doesn't fully solve that problem. Because the water that would overflow the river has to go somewhere. If you just push it back, it comes up somewhere else. So Tokyo built a second river, underground. That doesn't exist most of the time. When the real rivers get dangerous, the overflow diverts into the machine. The pumps kick in, and the whole system moves water at a rate that's genuinely hard to grasp. 200 cubic meters per second. That's an Olympic swimming pool drained every 12.5 seconds. And the entire system was designed to handle a flood that only comes around once every 200 years. Not once a decade. Once every 200 years, which means the people who approved this project were agreeing to spend 230 billion yen on something that might, statistically, justify its existence only a handful of times in a century. That is a very specific kind of bet, and it's the bet every flood-prone city on Earth is making, whether it admits it or not. This is what the title means by a billion-dollar system keeping a city above water. It's not a wall you can see, it's a river you can't see, held in reserve under the city, waiting for a storm that might not come for years. And that's why the build is such a hard sell, because you pay for it long before it ever does a single useful thing. The G-cans, as it's known, took more than a decade to build. Construction started in the early 90s and ran into the mid-2000s. For the entire first half of that period, the project was nothing but a massive hole in the ground, consuming billions of yen, producing absolutely nothing. No water moved, no flood was stopped, no person was protected. It was just a bill, arriving every year, with nothing to show for it. There's no product to hold, there's no service to point at, there's only a promise, and a very expensive one. If you're the government that approved it, and a decade goes by, and your citizens have never seen the machine do anything, it's very easy to wonder if you made a terrible mistake. It's very easy to cut the next payment. And that instinct, that entirely human instinct, is the thing every flood system on Earth fights against for its entire existence. Now here's the surprise underneath all of that. Finishing the construction is the cheap part. Once the cathedral is built, it stops being a construction project and becomes something else entirely. A company, a permanent, 24-hour, 7-day-a-week operating business whose only product is readiness. The G-cans has a staffed control room, with people watching screens that mostly show nothing happening. It has engineers on site, because the machine can't be trusted to sit alone. It has 78 pumps held in constant readiness, powered by machinery that burns through enormous amounts of electricity just standing by. It has maintenance schedules that run all year, because a pump that hasn't been tested is a pump that doesn't work. And here's the number that really tells you what this machine is. On average, the whole system actually activates around 7 times a year. 7. Out of 365 days, the billion-dollar machine does its job on roughly 7 of them. The other 358 days, it just stands there, consuming power, consuming salaries, consuming maintenance, producing nothing you can see. The pumps sit silent in a hall the size of an aircraft hangar. The control room hums all night. The electricity meter spins, and spins, and spins, and what does it buy? A day that looks exactly like yesterday. So let's do the math on what that actually buys. The point of the machine isn't that it runs. The point is that it's ready, and readiness is a thing you can price. In a normal year, the system eats electricity, staffing, and maintenance bills for 365 days, and then it earns its keep for a few hours on maybe 7 of them. But think about what it's buying in those few hours. One typhoon, hitting one low-lying district at the wrong time of day, can destroy more value in a single afternoon than the entire system costs in a decade. That's the whole economic logic in one sentence. Flood protection doesn't pay you back every year. It pays you back once, hugely in a single afternoon that might not come for decades. And if it never comes, you'll never know you got your money's worth. Japanese officials estimate that since this system came online, it has prevented more than 150 billion yen in damage. Floods that would have destroyed buildings, flooded homes, shut down the city, those floods never happened. Some estimates put the risk reduction for the protected areas as high as 80%, but you can't see any of that. There's no trophy, no ribbon cutting for the flood that didn't happen. The best you get is a photograph of the reservoir full of water after a typhoon, which looks to most people like a very large swimming pool that was left full by accident. And that leads to the question nobody asks out loud. Who actually pays for this, forever, and why do they keep doing it? Here's the thing. Flood defense doesn't have customers. It doesn't have a revenue stream. A restaurant can raise prices. An airport can charge more for parking, but a flood system produces nothing to sell. It produces a dry street, and you can't put a meter on a dry street. So every single dollar has to come from somewhere that isn't the system itself. In most places that means taxpayers directly. It means government bonds, repaid with interest over decades. It means maintenance budgets that have to compete, every year, with schools and roads and hospitals and everything else a city actually spends money on. And here's what the hardest hit places learned. If flood defense has to fight for money in a normal budget, it will lose. So the low-lying country that floods taught the harshest lesson, the one that lost thousands of people to a single storm in the middle of the last century, built a permanent dedicated system of water boards that have been taxing residents for centuries. Not because they're generous. Because they learned that the bill is either paid in boring installments forever, or it's paid all at once, in a currency that includes lives. The cities that stay dry are the ones that built a permanent dedicated boring machine for collecting money, so the flood system never has to justify itself in an election year. The cities that didn't are the ones that keep flood defense alive on the edge of a knife, funded by attention, surviving only as long as the last flood is still in living memory. Here's the trap that nobody sees coming until it's too late. A flood defense system is only as strong as its most boring part. The dramatic gates can be perfect, the tunnel can be flawless. But if the pump house was built with a design flaw that nobody wanted to spend money fixing or the maintenance crew was cut to save a few million, then the whole system has a hole in it. And the hole is invisible, right up until the day the water finds it. That's the structural weakness underneath the entire industry. You can't see the weakness from the street. The street looks dry, the city looks safe, the system looks like it's working, and all of that is true, right up until the one day it isn't. New Orleans learned that lesson the hard way. Before Hurricane Katrina, New Orleans was, by any ordinary standard, above water. It was a functioning American city with streets and schools and hospitals and people going about their lives. It had a flood protection system, levees, flood walls, pumps, all of it paid for, all of it maintained, sort of. But here's what the outside world didn't see. The system was old. Parts of it were designed for a smaller threat than the city actually faced. Some components had been patched instead of replaced. Some maintenance had been deferred because the money went to visible things instead. Reports had been written. Engineers had warned. Budget hearings had been held where almost nobody was listening. And then the storm came and the system failed. Not in one dramatic moment, in a sequence of failures across the weakest, most underfunded parts of the whole network. The levees broke. The flood walls gave way. Something like 80% of the city went underwater. Nearly 2,000 people died. The streets that had looked safe for decades were gone in a day. And that's the part that's easy to miss. The failure wasn't a surprise to the people who understood the system. It was a surprise to everyone else. The city looked safe. It felt safe. The streets were dry on the day before the storm, and they'd been dry for decades, which is exactly what made the danger so easy to ignore. The cost of every deferred repair, every underfunded upgrade, every boring component that had been postponed, came due all at once. And the total cost of that failure, in dollars, in homes, in lives, was astronomically larger than the cost of fixing every single invisible component that had been neglected. Afterward, the federal government spent roughly $14.5 billion building a new system, 350 miles of levees, flood walls, and gates. A $1 billion surge barrier that exists because the old system didn't. That's the whole subject written in one sentence. You either pay for the system before the flood, in boring installments you can't see, or you pay for it after the flood, in a currency that includes everything. And there's a second uncomfortable truth. Even when the system works, the job is never finished. The threat these machines are built against doesn't sit still. London's Thames Barrier was opened in the early 80s, a line of steel gates spanning more than 500 meters of river, protecting a city of well over 1 million people and a fortune in property. designed to hold back the tide through roughly the year 2030. Now they're reworking the math to stretch it to 2070, because the water is coming higher than the designers assumed. The low country that learned the flood lesson the hard way in the 1950s is still rebuilding, still updating, still paying, every single year. Venice built its famous system of mobile gates at more than 3 times the original budget, years behind schedule, after a corruption scandal that nearly killed the whole project. And Tokyo, the city with the most famous flood defense on Earth, is currently expanding its system because the rainfall events it was designed for are coming heavier than the original plans ever anticipated. Nobody builds a flood defense and then walks away. You build it, and then you rebuild it, and then you expand it, and then you expand it, and then you pay to keep it alive forever. Because the alternative is discovering, on a completely normal feeling day, that the bill you didn't pay has come due. So here's the honest answer. Keeping a city above water is not a one-time purchase, it is a permanent operating cost, paid every single year, forever, in exchange for a product you will never see. And that makes it one of the most difficult things in the world to fund correctly, because human beings are terrible at paying for things that don't visibly happen. Every day the system sits idle, it looks like waste. Every year the budget comes up, it looks like an easy place to save money. And the only way to know it was worth it is to imagine the alternative, which is a city underwater, and a bill that dwarfs everything you saved by cutting corners. So the real question was never about concrete or steel or pumps. It's about attention. The cities that stay above water are not the ones with the biggest walls. They're the ones that manage to keep paying for something that gave them nothing they could see, year after year, decade after decade, through every budget cycle and every election, long after the fear of the last flood faded. That's the actual system, not the cathedral under Tokyo. The decision, repeated endlessly, to keep the cathedral alive. So the next time you're standing on a dry street in a city that sits below the water around it, take a second to think about what's actually under your feet. Somewhere down there, probably, there's a machine. It's running right now. It's consuming power right now. It's got people watching it right now. And if you're lucky, it will do absolutely nothing today, and tomorrow, and for years. That's not a waste. That's the entire point. A dry city isn't a place. It's a machine in permanent operation. And the parts that matter most are the ones doing nothing you can see. The flood that doesn't happen isn't free. Somebody's paying for it, right now, under your feet.